Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Conformational analysis of butane involves rotating around the C2-C3 bond. The stability of conformations depends on torsional strain and steric interactions between substituents. Moving on to the next step. Identify the conformations shown. Option A. A gauche conformation where the two CH3 groups are at approximately 60 degrees to each other. This has moderate steric strain. Option B. An eclipsed conformation where the two CH3 groups are eclipsed, 0 degrees dihedral angle. This is the highest energy conformation due to maximum torsional strain and steric clash between the two methyl groups. Option C. An anti-conformation where the two CH3 groups are at 180 degrees to each other, fully staggered, anti. In the Newman projection, CH3 is at top on the front carbon and CH3 is at bottom on the back carbon, with H atoms staggered. This arrangement maximizes the distance between the bulky methyl groups. Option D. Another gauche conformation similar to A, but with a different arrangement, still has CH3 groups at 60 degree dihedral. Moving on to the next step. Apply the principle of conformational stability. For butane, the order of stability, lowest to highest energy, is anti-gauche eclipsed with HCH3, fully eclipsed CH3CH3. The anti-conformation, dihedral angle is equal to 180 degrees between the two CH3 groups, is the most stable because the two large methyl groups are as far apart as possible, minimizing both torsional strain and steric, van der Waals, repulsion. And for the final step, identify option C as the anti-conformation. In option C, the Newman projection shows CH3 at the top of the front carbon and CH3 at the bottom of the back carbon, a 180 degrees dihedral angle, which is the anti-conformation. Why other options fail? A and D are gauche conformations, 60 degree between methyls, which are less stable than anti due to steric repulsion between the methyl groups. B is a fully eclipsed conformation, both CH3 groups eclipsed, which is the highest energy conformation of butane. Therefore, the correct answer is C. Therefore, the correct answer is option C.